This is part 2 of the 11.1 to 11.3 video notes for honors geometry. And we're going to start off by looking at another scenario for triangles, because triangles are really the basis to find the area for anything that we want. And let's say we have this side angle side that we know. More specifically, let's say the length of this side is A, the length of this side across the bottom is B, and we're going to call that angle C. Now to find the area of this, I really want to do 1/2 base times height. The problem is A is not perpendicular to B, so A is not the height of this triangle. So we're going to do what we do in a lot of other problems, and that is draw an auxiliary segment. From the top vertex, I'm going to drop down this altitude. I'll call that H for the height of the triangle. Now looking at this yellow triangle, my goal is to find the height value of H. In that triangle, I know angle C. I know little a is actually the hypotenuse, and I know little h is actually the opposite of that angle. So I could say that the sine of angle C is equal to h over a. Multiply both sides by a little a times the sine of C is h, the height of the entire triangle. So the area of the entire triangle is 1/2 times the base of B times the height, which is a times the sine of C. And there's our area. Now, ideally, I don't want to draw in an auxiliary segment every time. So forget all that other stuff. Oops, too much. Forget all that other stuff and find the area of the triangle. All we need to know is that the area of the triangle is 1/2 times little b times little a times the sine of angle C. Using that, can you find the area for this triangle? And we're going to be switching back and forth in between screens. So go ahead and see if you can find this area, find it as an exact value and also as a decimal. All right, so here is the answer to that problem. It's exactly 36 times the sine of 80, and that is approximately 35.45 units squared. All right, going back to the notes. Go ahead and pause the video again. See if you can find the area for these next couple of shapes. We have a parallelogram. I know there aren't any markings for it, so I'll just tell you it's a parallelogram. And the bottom one is a parallelogram as well. You're given the length of this height is 10, this height is 12, and the perimeter of the entire shape, so adding up all 4 of the sides together, is 154. So go ahead and pause the video, try those problems, and when you're ready, unpause it. You can come back and check out the answers. Right, so we are back at the answers. The first example, I know the opposite sides in a parallelogram are equal to each other, so I looked at drawing in one diagonal and found the area of this one yellow triangle using 1/2 times 12 times 10 times the sine of 110 degrees. And then I doubled it to get to the entire thing, so the 1/2 didn't matter anymore. I could have just as easily done the diagonal that goes in this direction. Look at this triangle. 1/2 times 10 times 12 times the sine of 70 degrees equals this triangle. Double it, so the 1/2 is gone. In other words, you could use either 120 times the sine of 70 or 120 times the sine of 110 to get our decimal answer coming out to this. The next one is definitely more difficult. I know one way to find the area of this parallelogram is base times height, or 10 times x, that represents the area. Or I could say the base of y times the height of 12 also equals the area. And since the area of this parallelogram can't change, then 10x must be equal to 12y. The perimeter is 154. In other words, the x plus the x plus the y plus the y, all those added together adds up to 154. I divided everything by 2, solve for y is equal to this. Plug y in over here. Remember we said the area of the parallelogram was 12 times y. Well, it's also 12 times 77 minus x. Set this equal to this. We solve for x. X is 42. The goal was to find the area. Remember the area was 10 times x, so 10 times 42 gives us an area of 420 units squared. All right, next couple of problems, see if you can work through those. We have a right trapezoid. We have a regular pentagon. You're going to want to draw in some more auxiliary segments. Pause the video and see what you can do. For the first one, I would drop down an altitude, creating a rectangle on the right-hand side, creating a right triangle over here. The 13 means that this part of the rectangle is 13, so we have 4 left over. The tangent of 72 is equal to x over 4. Solve that equation for x. That is the height of our trapezoid. So the area of the trapezoid is the average of the bases, which would be 15, times the height, which is x. 15 times 4 is 60. Tangent of 72, or approximately 184.66. For the regular pentagon, I could draw in a segment going to each one of those vertices. A lot of times we call that a radius of a regular pentagon or any regular polygon. And then that gave us this yellow triangle. In here, I drop down a perpendicular of that yellow triangle, drop down an altitude for a regular pentagon or any regular polygon. Again, sometimes that's called an apothem. And in this left half of the triangle, I know that this split angle is 54. Normally in a regular pentagon, each angles are 108 degrees. So this is bisected at 54. Half of 20 is 10. So the tangent of 54 is equal to x over 10. So a little bit of algebra, x equals this. So to find the area of this one yellow triangle, it would be 1/2 times 20 times 10 tangent of 54. But there are 5 of those, so then we'd have to multiply that by 5 to find the area of the entire shape. So here is one of the triangles exact, and that would be times 5 or 500 tangent of 54, and then you can go to your calculator and figure out that decimal. All right, scrolling down further. Okay, so in this one, we have a regular triangle, which is a very special triangle. It's a pretty common triangle, and the goal is to find the area just using what we know about this triangle. The regular triangle, each of the sides is x, and also, if we drop down this altitude, it creates a 60, 90, 30, or more specifically a 30, 60, 90 triangle. X is the hypotenuse, so half of that would be x over 2, and this would be the short leg in the 30, 60, 90. So getting to the long leg would make this x root 3 over 2. So then our area would be 1/2 times the base of x times the height, which is x root 3 over 2. Now, if we multiply all this together, that gives us a numerator of x squared root 3. Multiply the denominators and we get 4. And this is a very useful formula for us. Anytime you have a regular triangle, to find the area of that regular triangle, you take the length of one side squared times root 3 over 4. Definitely a formula you're going to want to keep in handy. All right, last problem. I need to scroll this up. All right, so we have this drawing, and the goal is to find the ratio of area of triangle BDC to the area of this quadrilateral ABDE. Find the ratio of their areas given this information. Go ahead and pause the video again and give yourself a chance to work on this. Kind of a hard problem. One way to help you get started, it says that AB over BC has a ratio of 4 to 5. That means that this could have a length of 4, and this might be 5, or it could be 8 and 10, it could be 40 to 50, we don't know. So we're going to put variables after those to say, hey, these could be 4x and 5x, whatever x ends up being. Additionally, ED over DC is 1 over 7, which means this would be like 1y, and this would be 7y. So given all that, see if that helps you get started to find the ratio of those areas. Pause, and when you're ready, come back, and you can see the worked out solution. And here we are. For this front one, I said the area of this yellow triangle is 1/2 times 5x times 7y times the sine of c. This is our new formula given side angle side of a triangle. There it is, and there it is simplified. The area for the entire blue triangle is 1/2 times 9x times 8y times the sine of c. Multiply that out, it comes to this. So there's the yellow triangle, and there's the whole blue triangle. We want to find the area of this green one. And if I think about that, it would be the blue area minus the yellow area, what gives us the green. So 72 minus 35 means that the green area is 37 xy sine of c over 2. And the ratio would be this yellow divided by this green, oops, this green in the denominator. So 35xy sine c over 2 divided by 37xy sine c over 2, multiply by 2, get rid of the xy sine of c's, and we get a ratio of 35 over 37. That is the end of notes part 2.